Hello everybody, welcome into another lesson. So today we are going to graph inequalities. So I'm going to show you how that works. Here we have y is greater than or equal to 4. So y is greater than or equal to 4. If it's greater than or equal to or less than or equal to, if it has the equal component, what you do is start by drawing a solid line through y equals 4. Y equals 4, as we recall, has a nice solid line going through y equals 4. It's a nice solid horizontal line. The reason for that is a whole line denotes that you include y equals 4 in the solution to your graphing. Alright? Because if it's equal to, you got to include y equals 4. Then what you do, it's fun here. You just shade the entire region above it. Since y is greater than or equal to 4, you're just going to shade the entire region above y equals 4. Yeah, this could be trying on the markers for sure, but just get a nice representation here. It's going to look like a mess, but basically you draw a nice solid line through y equals 4, then you shade the entire region above it. The reason is because we're going to include y equals 4, and then it's every value greater than 4 also. That's why the shading. So that is exactly why we do what we do with that, because we're including not only 4, but all numbers greater than 4. Let me get another marker here. Might need it. Alright. So that's if y is greater than or equal to 4. Now, do a slightly different inequality. Somewhat similar, but slightly different we're about to do. What if we simply had, this time we're just simply going to have y is greater than 4. So y is just greater than 4. There is no equal to part, alright? We have y is greater than 4. So if it's greater than or less than, you're going to go to where y equals 4, but this time you're going to draw a dotted line. You're going to draw a dotted line through y equals 4. So the line is dotted. The reason why it's dotted is that means you're not including 4 in the solution. So it should still look somewhat like a horizontal line, but it's going to be at y equals 4, but the line is dotted because you don't want to include that in your solution set. But like you would with the greater than or equal to, but it's greater than 4, you're just simply going to shade the entire region above that y equals 4 with the dotted line. So just take your marker or whatever, shade the entire region above that y equals 4, because this time you don't want to include y equals 4. That's why it's a dotted line, but y is every value greater than 4. So that's what graphing y is greater than 4 would look like. So graphing simple inequalities really aren't that bad. It's just a lot of shading. Alright, how about if we had something like x is less than 1. So this time we have x is less than 1. Well, it's just less than, so we're going to draw a dotted line through x equals 1 because we don't want to include x equals 1. So basically it's going to be like the graph of x equals 1, only it's a dotted line because we don't actually intend to include x equals 1 as the solution. So let me just draw my line here through x equals 1, but it's going to be a dotted line because it's just less than 1, so we don't want to include it. So there's the line through x equals 1, but it's dotted, if you notice, because we don't want to include x equals 1. Then you'll just shade the entire region to the left of 1. So it's going to look like a bit of a mess here because it's going to be all over the place. We're going to have some shading in all 4 quadrants, which is really not going to be a good day for this marker, I could tell you that. Then you'll just shade the entire second and third quadrant. I'm just kind of pseudo shading it. You'll be able to see that the entire thing is going to be shaded to the left here. Yeah. These can get real hairy real fast. But what I've done now is I have shaded everything to the left of x equals 1 because x is less than 1, so it's going to include all values less than 1. That's why you shade everywhere else to the left of 1. And then you have a dotted line for x equals 1 because you're not actually including that itself. Now, if I were to change this to x is less than or equal to 1, not a whole lot changes. The only difference is this dotted line now becomes a solid line through x equals 1. So if we had x is less than or equal to 1, you get a solid line at x equals 1 because now you're actually including x equals 1 as the solution, and then you still keep the shading to the left of it because it's every value less than 1. So that's the difference. I know this one was pretty horrendous. Easy enough to understand, just kind of an eyesore for graphing it. Just bear with me a minute. I got to get rid of all this crap in here. I really painted my board red, that's for sure. Almost there. That was kind of an ugly example, but had to be done. Alrighty then, I think we got it. There we go. So, what's the next one? No, I think we've seen those types. has me doing x is greater than 0, which is really, well, if we did x is greater than 0, I guess we'll kind of do it. So x is greater than 0. Well, what you would do next is draw a solid line through, a dotted line through x equals 0. I'm not going to draw it because that coincides with the y-axis, because that's what that would be. X equals 0. You get a vertical line, but it would be a dotted line since it's just x is greater than 0. Then you would shade the entire regions to the right of 0, because it would be every value greater than 0 for x, but not including 0 since it's just greater than. So that's what you would get there. Then let's say we did y was less than 0. So y is less than 0. So since it's just less than, you would draw a dotted line through y equals 0. I'm not going to do that because that coincides with the x-axis. I don't want to mess that up. So you're not going to include y equals 0. That's why it's a dotted line through y equals 0. Then you would shade everything below y equals 0. You wouldn't shade the entire third and fourth quadrants. So yeah, I think you see why I'm not just graphing that, because we could be there all day trying to do that. But how about y is greater than or equal to -1? So we have y is greater than or equal to -1. Well, since it's got the equal component, you would draw a solid line through y equals -1. Since it's got the equal component, that means we're going to include y equals -1 in the solution. And then what you're going to do is you're going to shade the entire region above y equals -1. So you'll have all this and all this shaded. Don't think we need to spend a lot of time on that. I think you get the picture with basic ones like that. Then let's say we had x is less than or equal to -4. So x is less than or equal to -4. Well, since it's got the equal component, you would draw a solid line through x equals -4, because we're going to include x equals -4 in the solution. That's why it's solid. And then since x is also less than -4, you're going to shade everything to the left of x equals -4. So that's really, I think you kind of get how to graph the single variable ones with x and y. Now let's shift a little bit. What if we had something like y was less than x plus 5? Alright, so now it's changed a little bit. We have both variables in the equation, and it's just less than. So this tells you we're going to have a dotted line, which means we're not going to include the line itself in the solution. Well, what you need to do is figure out how to graph the line. First, start with y equals x plus 5. We're going to draw a line through y equals x plus 5. So when x is 0, y is 5. We'll still have a little point here. And then when y is 0, x equals -5. Now, we're going to connect these two, but we're only going to use a dotted line. The reason being is because we don't want to include the line itself in the solution of the graph. So there's a nice dotted line through y equals x plus 5. But again, it's dotted because we don't want to include the solution. But yes, how do you graph y is less than x plus 5? Well, what you're going to do now to graph it, you're going to shade everything below the line. Since y is less than that line, you're just going to shade everything below that line. If it were greater than, you would shade everything above. But it's less than, so you're going to shade everything below that line. And this is where it gets interesting, because it's no longer just shading solid quadrants anymore. You're shading the entirety of everything below the line. Since you want all values less than that line, you're going to shade the entirety of below the line. And I think you get the picture with what I was doing with the shading. So you have your dotted line through y equals x plus 5, because we're not including the line itself in the solution. Then if it's less than, you shade everything below the line. That's all that is. So that's how you would do that. Still pretty much graphing the normal line, but this time we're we're shading below the line. Why a lot of people prefer not to graph inequalities, because you see it can get very ugly very fast. But I gotta show you how to do it, because it will come up in an algebra course. We'll get there. Let's get that little bit here. And then now we're down here. Good. We're almost done. We're almost done erasing the shading. Alright. Let me reconnect my axis a bit, since I kind of messed it up a little doing all this. Alright. Let's see, what's the next one? Well, I have about 3 more problems and we're done. I have y is greater than negative x plus 1. So this time we have the inequality y is greater than negative x plus 1. Well, since it's just greater, we're going to draw a dotted line through where y equals negative x plus 1 would be. So when x is 0, y is 1. So we'll have that point here. And then when y is 0, x equals 1. So now we're going to draw a dotted line through these 2 points and then keep extending it. Basically like you would the normal line. Yeah, we'll go to about there. Drawing dotted lines ain't very pretty, is it? Drawing dotted lines is not very pretty. So we got the graph of y equals negative x plus 1, only it's a dotted line because it's just greater. We don't want to include we don't want to include the line. Now once you've drawn that, since it's greater than negative x plus 1, you're going to shade every region above it. You'll shade everything above that line, which would look like this. Since it's greater than negative x plus 1. Yep, we got quite a bit more shading here. So that's what you would get for your solution. You're including everything greater than negative x plus 1. That's how you would graph that. I have about 2 more and we're done. Alright. Next, let's see. Y is less than or equal to 3 minus x. So we have y is less than or equal to 3 minus x. So we want to, this time, since it's got the equal component, we're going to draw a solid line through y equals 3 minus x. So when x is 0, whoops, I better fix my axis. Better fix the axis here, eh? There we go. Alright, so when x is 0, y would equal 3. So that would go here. And then, when y is 0, x would equal 3. So that would go here. Alright, so you're going to draw a solid line here, since it's got the equal component. The reason it's solid is since it's equal, we want to actually include that line in our equation. In our solution. So now you have a nice solid line of y equals 3 minus x, because we want to include that in our solution. Then since it's got the less than component, you're going to shade everything below the line. So everything below the line here is going to be shaded, because you want all points less than that line too. Yeah, I know the shading's kind of a pain in the butt. That's the worst part about graphing these, is all the shading you gotta do. I'm just giving you a roundabout idea. I know I'm making a mess of this, but it'll suffice. It'll do the job. So yeah, that's how it's going to look here, because y it has a less than component, so you do everything below the line for your shading. Then I have one more, and then you are done for the day. Good thing there aren't many examples today, because doing this is a bit time consuming per problem, as you can see. But it needed done. I wouldn't be doing my job if I didn't teach you how to do this, because this does come up in algebra courses all the time. Okay, last problem here. Y is greater than or equal to 1 minus 3x. So y is greater than or equal to 1 minus 3x. So since it's got the equal component, we know we're going to have a solid line for the graph of the equation. Now, let's see here. Let's just find a couple points to plot them and draw our line. We know when x is 0, y would equal 1, so that'll go here. Alright, let's see. How about when x is negative 1? So 1 minus, that'd actually be 1 plus 3, that would be 4. Alright. Then when x is 1, you would get negative 2. Good, so we actually got 3 points to graph here. Yeah, roughly about there. Okay, that works. So there's your nice graph of y is greater than, well, there's y is equal to 1 minus 3x. Now, we have the greater than component. So, we want to shade the region where y is going to be greater than 1 minus 3x. Well, that's going to be above the line, or it looks kind of to the right of it with the way it's tilted. But you're just going to shade everything to the right of it, or technically above it still. So yes, I'm shading all this wonderful stuff here just to illustrate what it's going to look like for your solution set, because it's also everything above the line. Thankfully, there's only one more lesson like this, and I'll explain at the end of this lesson what it's going to be. Alright, so for your solution set to this, you got to take, since it's got the equal component, you draw a solid line through y equals 1 minus 3x. And then, since it's got the greater component, you're going to shade everything above the line, or I should say to the right of it. It looks like it's almost to the right of it, but really that's above the line. So since y is greater, and that's how you would do it. So that's it for graphing basic inequalities. On the next lesson, we're going to graph systems of linear inequalities. So we're going to have some systems of inequalities. So it kind of goes back to solving systems of equations, but instead of equations, we're going to have systems of inequalities, and we're going to graph the solution to those. So I hope everybody has a good day. Take care.